Good morning, good afternoon. Once again, it will depend on the time that you are joining the course, and I hope that you are doing good. For me, I'm good. And then today we are going to focus on vector as one of the data structure we have seen in other programming. Of course, we have seen many, but we are starting on the vector. But I think you understand what is vector. We have seen that is one-dimensional or data structure where it has one data type, or it's like when we need to use a vector at the time when we are creating an object, and then the object that we are creating, it is assigning more than one thing, and we will use the concatenate uh, data to store that kind of information that we really need to use. And then the one of the characteristic of the vector also it consists of one data type, and you understand that the vector can be numeric vector, categorical, logical, whatever and whatever. It will depend on the data type, but we are focusing on only three data type as a common, but not limited to. If you know more, it will be good, but we are focusing on this because this is the most popular. So as I said, when we are trying to formulate the vector in our programming, most of the time we normally use the data code concatenate. We use concatenate function to assign the difference, to assign the values to the object. So why we use concatenate is it is because we normally know that when we are generating object, we used to use the equal sign or less than or minus to put the exact values. But if we need to assign more than one value to the object, we will need to use the concatenate. So as an example, we have here, we have the friend's age, where we need to assign more than one age, like almost a four age, we will use concatenate, and then we put this. This is also the numeric. And then for the categorical, we have seen that when we are dealing with the categorical, we have to put into the quotations so that we can tell other programming that we are dealing with categorical. So if I say categorical, just understand the character. That's what it means. So most of the time it is the same. And I can have also the vector which is logical, where we have seen that the logical data type we normally have true and false, and this is also the logical vector. And here there is another way also we can generate the vector by using dot, where if you say that I need the ID from 1 up to 4, that's what it means. Is it going to print the value from 1 up to 4? And this is also the numeric. You see, this is the result. We are going to see it in practical. And from here, you can also generate the vector by using replication function. This is what we call replicate. So we used to say that the name of object, and then we put equal or this kind of things. It is the same as equal, assigning operator as we have seen. So we put the replicate, and then we said we want Nicole, Thierry, Bernard, something like that. And then we need to be replicated into two timers. That's what it means. So even for the numeric, you can do it, but keep in mind that you replicate to help us to replicate the values to the extent we want. So you can say that I want to replicate it 3 times, 4 times, it will depend. What we are going to see, we are going to see Nicole. We are going to print the double my friend. We are going to see Nicole more 2 times, CLE 2 times, and another to other until to the Jerome. And also here it is replicating my friend in 2 times. You see, sorry, this was the comment of above. And also you can double the indexing each by 3. That's what it means. You see, so for the numeric, we can't say times, we use each. This means that is going to be pair into 3 times. And also here we are talking about, we will see how we can name the vector. To add the name to the vector, we use the function names, and it is used when you are trying to add the name to the vector. So we have friend's age, but we can say that instead of saying that the friend's age, we can add at the same time we take the friend's age and then we add my friend. So we have two vector. One is for the age and another it is for the my friend. So we need to tell the other that where we have an equal, I want you to link with the age that has. So what we need to know before doing that kind of things, we need to make sure that the number of values are equal. If I have 1, 2, 3, 4, I want to make sure that on the age it is equal to 4. Otherwise, it is not going to work. So if it is equal, we will use the names where we put the friend's age equal to my friend. So, or you can use friends' names, you can say friend's age, and then you say concatenate, and then you type it the way you want. But the best way we used to use, this is the best way we can use when we are trying to focus on those kind of things. And then uh, another way we can do also here, it was like we are trying to print the output to see what was happen. And also here there is another way of checking the missing value, where when we are trying to check the missing value, this is also the missing value. So the function we use when we are checking the missing value, so we normally use when we are checking the missing value, so we normally use is.na. So that is what we used to use. So sorry, for the missing value, we use is.na. We put the name, and what we call the missing value, it is na, null value. That's what we mean. To check the missing value in a vector, we use is.na, and we are going to see it in practice. And here it is subsetting the vector. If we say subsetting, just understand that maybe we are a group of people, but we need, there is a list of numbers. So there is a list of students. So I need to pick maybe people who are like in 5 positions, something like that. That's what we call subsetting. So I'm looking for the group, but inside the group, I need specific numbers. So that's what we call subsetting. It is the same as to the vector. Let's say I have the vector of more than 11 or more than 20 characters. So, and inside that character that I have, I need to pick only 2. I need to put what is on position number 4. That's what we call the subsetting vector. That is the logic of using subsetting. And of course, when we are talking about subsetting, so we are going to use the brass. So there's the square bracket. I used to say that is a square bracket, but it is a brass in technical term. But what I'm interested in is just to understand what I'm talking. When we are using the brass, we are trying to look for the specific position, specific index. We are doing indexing in technical term. So as here an example, we have the object called my friend, and within my friend there is a lot of name, but we need to see who is number 2, who is in a position number 2. You see that the result is telling us it's Thierry. The same as to here, I need to look for number 2 and number 4 at the same time. And here I want to see from 1 up to 3, from the person who are in position 1 up to position number 3. But position number 1, position 2, and to position 3, something like that. So that's what subsetting also means. So for that time, maybe you are asking yourself that what those kind of things is going to help us to solve the real world problem. But our intention, you will see it to the large data set. So to the large data set, when we are trying to analyze the data, there is a time where you will need to specify the information. Let's say, for example, I have a big data set, and I want to see who has the ID. Let's say I have the ID, and then I'm interested to see who has if it is the ID number 4, who has the ID number 4 in terms of age. That's where we will see subsetting. So the removing some element in a vector, we use minus. Of course, the sign is the same, but the operations, like it is the difference. That's how it is a difference. For the first time when we are doing subsetting, we are trying to see. But if we are going to remove, still we are using the square bracket or brass. But if I need to remove uh, I need to remove the value to the position number 2, what I'm going to do, I'm going to do minus 2 instead of typing 2. Typing 2, it's like to print the exact value that is in position 2. But if I need to remove, so I will use the sign of removing so that it's going to be good. So if I remove this and then I print my friend, automatically that value that is in position 2 is going to be omitted. So the same as here, I remove the values that is in position 2 and 4. You see, I will see only values that is in position 1 and 3. I'm omitting my friend to the number 2 and 4. And the same as here, from 1 up to 3, I'm going to get Jerome only where it is on the last position, number 4. So the removing some elements, still that's what we are doing. So to remove the missing value in a vector, I will use of course, before we see how we remove the missing value, at the first time we have seen that to check the missing value, we use is.na. When we add this exclamation, when we add the letter exclamation at this time, it is telling other that go and remove that missing value. So we say we put the name of object that we are interested to look for the missing value so that we can remove it. We use the square bracket, we use exclamation is.na bracket and then put the same name that you have, like the object you're really interested to remove that missing value. And then since we are having the missing value, we are going to remain with the code and yes, something like that. That is what we are going to see. And also replacing the missing value with other to the vector. Of course, I'm going to say, we say has square bracket is dot na has something equal to no. Go and check where there is a missing value. That's what it means on the have children variable or the object and equalize with no. You see, that's what it means. Where we have no, maybe we was having a missing value to the Bernard and also Jerome. So that's what it means. The calculations with a vector, in a vector you can make addition, subtraction. The way we did it for the operations or operators, the mathematical operators we have seen on introduction to Arab programming. So, but what we need to put much effort, what we need to know is that you cannot sum something which is not equal, and you cannot sum or you cannot subtract the difference in data type. Of course, you cannot say that I'm going to add the vector which is numeric and the vector which is categorical. So we need to be aware of that kind of information. So not only that, but also you can multiply, you can do also subtraction. And this is what we are going to see. You can also calculate the maximum salary. Let's say, for example, I was having like the salary variable, where the salary variable it is composed by the 2,180, 2,050, 3,000, something like that. And then I can multiply with 5, or also I can using a salary, can also calculate the maximum among the numbers, minimum, range, range it is to see getting the number of element in a variable on the object. Let's say I have the object called x or age, and within age I assign it a lot of values, but I don't remember how many. So if you need to know how many of course, you will use the ref to see to know it. And another thing we have to know is that so you can also look for the product. You do the product, mean, standard deviation, variance, sorting from A to Z. You see, we are sorting the element in ascending order, setting element in descending order. Those are kind of things we will need on the data manipulation, but I want you to see how it works. There is a bit similar when it comes to the data frame. As I told you, if we say data frame, just understand that it is a data set in simple in real life situation. But when it comes to the other programming, we don't say the data set, but also we say the data frame. So, but we will see it in next session. And this is a conclusion. A vector is the simplest and the most common data structure in R. It is a sequence element of sample of the same type. If I say the same type, you cannot have a vector that has both data type of numeric and categorical at the same time. What is possible to the vector? Vector should consist of one data type. We can have the vector of numeric, we can only independently, and also we can have the vector of categorical independently. But we will see to the other structure of the data where we have a possibility of having more than one data type at once, especially when it comes to the data frame, as of course we interested to play a role with the data frame. So this is also where you can get the practical task. So uh, I I think now we are going to focus on the practical session. So what is a vector? As I said, the vector is a collection of elements in the same data type. It is only most important data structure. It is one of the important data structure. Here I'm generating the numerical vector, which is equal to numerical vector. When I run the numerical vector, this one, so what you have to do is like to run this. You see I'm running the numerical vector. I use the data concatenate C 1, 2, 3, 4, and 5. And then this is the numerical vector that I was interested to show you, but also this is the categorical vector where I have Rwanda, Uganda, and Kenya. Because it is categorical, we have to put like the quotations to tell other that this is the categorical so that you can understand it very well. So from here you can run and then you see the result. And not only this is an example of the logical vector where we have the true, false, true. If I run this and then I print, and of course we have seen that there is a possibility that where I can print by typing this one. So if I say print, like, and then I say log, uh, vector, logarithm vector, I can write print and then I put the name of object, or I prefer to put the name of object and then I run. So here we are creating the vector by using concatenate C. So it is the same thing that I was doing here. So it is like the repetitiveness, but apology for that. But what I'm interested to show is like knowing how it works. So the way we do this, you can also do the same, something like that. Sequence, you can also do the same. That is another way we can also generate uh, the vector by using operators, sequence operators, where the sequence operators that we are saying, this is the sequence operator. So this is V4, vector number 4, we are trying to generate the sequence operator from 1 up to 10. So once I run this is going to be working. And here when I print, you see when I print V4, so when I print V4, so this is going to be from 1 up to 10, but here I was generating from 10 to 1. So when I print V5, interestingly, so when I print to 5, I'm going to get from 10 to 1. So it is depend on the way you organize it. Of course, you can also say that I want to from 100 up to 120, something like that. So if I run again, so I'm going to see from 100 up to 120. You see what you need, it's like to specify the lowest and the highest in a range. and then R is going to understand it so that it's going to help you. So here we are trying to use the sequence function to see it from 1 up to 10. There is another way we can use the sequence function when we are generating like the vector, the numerical vector. So we are trying to use the sequence function where we use the sequence, we type the seq, and then we open the parentheses from 1 to 20 by 2. It is going to get this by adding 2. I can say not multiple. We are trying to look for the values in between 1 and 20, which is not divided, which is not divisible by 2. That's what it means, okay? Which is not divisible by 2, and then you see this number is not divisible by 2. And this is another way also we can generate the vector by using replication function. We are repeating 5 into 4 times. You see, I use repeat and then I put 5, and I'm going to create the vector number 7, which is composed by 5 into 4 times. So when I run the V7, you see 4 times, and the same as here, I'm going to generate the vector called V8, which is going to which is going to be composed by A and B, and it is also composed by, it is going to be duplicated into 3 times. So this is also what I'm going to do, and once I run V8, I see A into 3 times. This is interesting. And also to check for the vector data type, you see vector can only hold elements of the same type, and R automatically, if you mix this, is not going to work, you see. So if I run this, you see I have Rwanda, you see. So since I do this, so I'm interested to see for the class. This is not going to be vector. So I want you to see this is not going to be vector. You see numeric, because this was the numerical vector we created before. But what we are going to check, this is a mixed vector to see if it is going to be continuing something. So it is also the character, because I mix numbers and country and ara, because you cannot say that numerical character. So the ara, they understand it as character by default since we have this one. So it is possible to not making quotation since we have those kind of things and we are mixing it. So you see now it becomes a character, and assessing the element or indexing, what we are saying, it's like subsetting. If we say subset, sample subsetting, it is the same as also indexing. So sorry, it is the same as also, or I want you to look for this. Okay, so subsetting or indexing. So that's what I'm trying to do. We have to say subsetting or indexing. Sorry. Okay, indexing. Okay, and here we are indexing from 1. Okay, indexing, we are indexing what you need to know, some programming language. This is important to note it. So some programming language, the value that is in position 1, especially for Python, we started counting from 0 up to n minus 1. So, but in R, the value that is in position 1, the indexing, like the ID, the location of that value that is in position 1, we count from 1 up to the n, which means when I need to see the values to index 20, I will say that I need the observation that is in position number 2. So we count from 1 up to, but for the Python, it is not the case. We count from 0 up to n minus 1. which means for the sake of Python, if I have 5 observations, for me, when I'm interested to make indexing to the Python, when I will need the value that is in position number 5, I will use a 4. And then if I say I need the value that is in position number 1, the position 1, I mean number 2. It is the value that is in position 2 in Python. But for us, let's focus on other programming. If I need 10, I will say 1 up to. We count from 1 here. So if I index in first element, I'm indexing the first element. You see, V not defined. I didn't run V, that's why I get V not defined. And of course, you will see that on the output window, on the other console, the value it is somehow matched. So you want maybe to clean it. So you see these kind of things, that kind of things. You see, it's like the spider, the clear console. If you put the cursor here, you will see the clear console. If I click on clear console, automatically things are going to be um, excluded. So again, from here, another thing that we need to put much effort, I'm indexing number 3. I'm indexing from 1 up to 3. I'm indexing 1 and 4. I'm removing negative indexing, excluding elements. That's what it means. I'm removing number 2. I'm removing 1 and 3. I'm removing logical indexing. Also indexing the value that is above 25. So what it means, it is going to go to the vector, it is going to go to the vector v or the object in called v and look for the vector v and look for the 20 element that is on 20 above 25. So when you look at the V we have 10, 20, 30, 40, 50. So when we say that we need the element that is greater than 25, it means that we are going to get 30, 40, and 50. So if I run this, you see, if I run this, I need values that is above 20. So this is also what we need to put much effort. And also, if we are modifying the vector element, we are modifying from 10 to something. So we need to replace. Here also, there is a possibility where we can sorry, sorry. There is a possibility where we can replace the vector in a position number 2 with 25. That's what we are doing. So which means on the position 2 we have 20. So if we are doing this, we are saying that we need to replace 25 with 20. So that's what we are doing. Of course, if I run this, you see, and then then here I'm indexing the values. Again, I want to change, I want to modify the position, the values from 1 up to 3, and then go and replace it with 5, 15, and 25, which means it's going to replace this one, and this one, you see. So when I run this, very sure that what I'm going to do, I understand it. But when I print this one, you see it is automatically changed from 5, 15, 25, something like that. So then vector operations, we also creating the vector. I'll make the addition, subtraction, multiplication, division. So what I need to look for before doing that kind of things is to make sure that the number of elements, the number of values that is assigned to each vector, it is equal, but also having the same data type, because we normally doing this for the numerical vector, and we have to make sure that all of the vector that we are applying those operations, either addition, subtraction, multiplication, and division, and also even modulus, but here it can't work for the making with combining more than one thing. So you have to make sure that elements are equal, the number of elements are equal. So here also I can do multiplication, scalar, For those who knows mathematics, scalar operators, you see, this is also something. Here, what I'm doing, I'm going to look for the vector number 2 and go on each element and then add 5 for each element. Here we are multiplying each element by 10, which is interesting to us. So I know you know those kind of things. And useful vector function. Here I have the vector code V. It is consists of 5, 10, 15, 20 to 25. And here I can see the rank to see the number of elements that is applied to the vector V. So if I run this, you see I have a 5. If I count, let me count and check 1, 2, 3, 4, 5. Of course, it is a 5. Sum, we are trying to make the summation of this element. Of course, this is what happened to the number, which is to the vector, which is numeric, cannot happen to the categorical or character or the logical data type. It is applied to the numeric. I want you to note this. So, and also here you can do the summation. You can also calculate the median, minimum, maximum, range, sorting from ascending to descending, from ascending. We are here sorting from descending. We are making reverse element. If we say the reverse element, it was from 5 up to 25, but if we are reversing, it is from 25 up to 5. Those are the kind of things we need to know. And here also, we are checking if 10 is in V. We have vector this, we have vector which is equal to 10, 25, 30, 40, 50, and then we are trying to check. If 10 is in vector V, it's going to tell us if it is in. If it is in, it's going to give us true. If it is not, it's going to give us false. You see. Here again, we are trying to see if 25 is in V. If it is there, it's going to give us true. If it is not, it's going to give us false. So I want you to understand this. Which V that is going, which V. Here we are trying to check which position on the vector on the object called the V has the value equal to 30. For us, we have 10, 20, 30, 40, 50. So what is going to bring for us is going to give us the 3, which means that on the position number 3, that's where we have the value which is equal to 30. So interesting, you see, it's going to give us 3, and we need also to know those kind of things. Here we are naming the vector element. As I said, if we are naming, have a vector which is equal to V, called the V is equal to 100, 200 to 300, and then when we are using a names V, when we say math, science, English, something like that, you see, I'm trying to say that math they get 100, science they get 2000, English they get 3000. You see, how are we going to do those kind of things? We have to run it faster. I have to print this. Already I did, you see. If I say names and then I put the name of object that is having a number, and then I equalize with things that I need to to equalize with, automatically see what I have. Math is equal to 100, science is equal to 200, and English is equal to 300. Again here, I want to access by name. I want to access the science. You see, if I access the science only, I will having the science, and from here I can also access it. Maybe I can access another thing like math. Let's say if I want to access math only, so math is not equal to the way it is. I'm accessing math, so I get any. The reason why math is not typed the way it is, I use the small letters into capital letter. You see math is equal to 1,000. Another continue to do the same. Logical vector on filtering. So here we are filtering. I'm filtering greater. I'm filtering the things which is like here what I'm doing, even element. So I'm trying to look for each value that is in a vector V and to see if I take that values that in position, that values that are assigned to the vector V and I divide by 2, I will get 0. That's what it means. That means we are trying to see the even numbers among the vector V. So you see, and then here we are trying to see the things which is not even number, odd number, things which is not divided by 2. And I said this exclamation means not. It is means not equal to 0. Not equal to 0. Since we have seen that those two stuff, it is said it give us the reminder. So this was like we have seen it in introduction to R programming, where we have seen that when we are using 2%, we are trying to see the reminder. So here we are trying to see the element in vector V, which is divisible by 2, and then we get 0. And here we are trying to see the element in vector V, which is divisible by 2 and not give us 0, which means there is a reminder which is totally different to 0. So that's what we are trying to see. That is that number 25 and 45. So combining and recording. So we are having vector 1 and vector 2. We can combine the vector 1. Vector 1, if we say the vector 1, you see what I was telling you. So you're not going to get it interestingly because you see it is not equal. No object are not equal. That's why it is not going to be getting the result. As I said, if you are trying to make the addition on the vector, you have to make sure that the elements are equal. I was putting this so that I can challenge you to keep in mind that when you are doing operations, you have to make sure that the elements are equal. So here, uh, we are trying to convert to the vector. So I have a list. This is a list of numbers 1, 2, 3. But if I say as dot vector, I'm trying to convert the list into vector. I have my list here, and if I say as dot vector, I put the name of my list called my list. Automatically, when I change, this is going to be, so this is what I'm going to see, the vector from 1 to 3. So that's what it means. So this is also the additional practical exercise. You can try to do this exercise, and then feel free to ask any question regarding to the practical assignment. If you have a question, feel free to ask in a chat so that we can help you to understand the vector as much as we can, because really it's going to help us when we deal with the data frame, especially when we are focusing on the data manipulation. So we are playing with this so that you can know how you can make indexing, so that you can know how you can calculate subsetting, doing subsetting, calculating a mean, mode, median, those kind of things. But I hope when you are building a function, sometime, or when you are building a function or the pipeline, you will see it on the side of making a dashboard. So we will see the applications of a vector, applications of a factor, loop. We are going to see it in next session. So thank you so much once again. I hope you enjoyed the session. Um, I wish you to be with a God. God continue to guide you in everything that you are planning to do. So let's meet on the next session.